So my name is Noah Levine. I am currently in the MFE program at Lehigh University, and I recently graduated my undergrad from Lehigh with a BS in finance and a BA in statistics. And today I'm going to go over my capstone project, which is company risk classification using natural language processing. So first, the overall goal quickly. It's to engineer some sort of model that can determine whether the CDS spread will increase or decrease based off either positive or negative sentiment in a quarterly earnings call transcript. So what is a CDS and why did I choose to use them in the project? A CDS is simply insurance against a corporate bond. So if you are a mutual fund or a hedge fund and you want to invest in, say, FedEx's triple B rated bonds, you might not be allowed to because there's some stipulation in the contract that says you can't invest in, riskier debt. So what you can do is you can buy a CDS, which is a credit default swap, which allows you essentially to pay a premium. And in the case that um, FedEx does default on their debt, you get paid back the principal. So they're priced they're priced based off a basis point spread, which is the difference between how the corporate bond trades and how the treasury trades for the same duration. And you can see in the chart here, this big spike is COVID, meaning spreads, the amount of premium that you're paying basically increases because the overall environment is riskier. And this is during COVID, like I said, and this makes sense. So here's just a graphic of what they look like. And the reason I chose to use them is because, with equities, there's been a decent amount of work done, especially when it comes to earnings call transcripts and natural language processing. But not much has came out yet about how the language in earnings calls can actually affect the the risk, the underlying risk of the company, and therefore the CDS spread. So to start, I had to collect four different uh, types of data. First was the earnings call transcripts, and this was from a GitHub repository, which I found online. It had thousands of transcripts from companies in the S&P 500 uh, from 2017 up until 2022. And then I had to find the CDX index, which is sort of like the S&P, but for credit default swaps. And I had to align, create a data frame that align the CDX tickers with the S&P tickers found in the earnings call transcripts. So then I had to use CDS spread data, which obviously is the time series information from Bloomberg. And I collected the 5-year spreads and 5 years worth of data, of daily data of the spreads from the Bloomberg terminal and imported this to Excel. And then finally, I had to use this Lauren or Laughlin McDonald lexicon, which essentially is a CSV file which categorizes every single word in the dictionary based off positive or negative sentiment. So the next part was to essentially use some sort of model to allow the computer to understand the words in the transcript. And this is where we found Spacey, which is which is a package in Python that allows computers to understand words and turn them into numbers essentially. And there's, a few different features of Spacey. One of them is tokenization and lemmatization, which is sort of, the example you can see below. You can break a sentence down into its individual words, and then you can break each word down into its underlying root words. So like running is just run. And this is what Spacey allows you to do with a corpus of text. Then it also removes certain stop words, unnecessary words. Like here, you can see for the bottom example, I like reading, so I read. I and so aren't necessary, so they're not including. And we want to, for the efficiency of the program, we want to remove as many stop words as possible. And then finally, there's something called TF-IDF vectorization, which is how you can convert numerical how you can convert text into numerical representations. And below is an example of how this might work. So if you have some kind of review of movies, you have 3 different reviews. Words like, you can see this is in every single is in every single review, so it might not be that important. But words like scary, which are in only 2 of 3, would be considered some important, so they have some values. That's essentially how this vectorization works. So next was to figure out how, the transcript was actually positive or negative. So we use this Lawford-MacDonald dictionary, which has, like I said, has every single word in the dictionary. You can see on the left, and on the right, it has, whether it's positive or negative. And there's some other sentiments that we ignored. So what we ended up doing was calculating something called a polarity score, which measured sort of how how positive the transcript was, how much positive sentiment there was. So a higher polarity score above 0 means that there's more positive sentiment, and below 0 means more negative sentiment. And these data points here are connected to the 6-day return, which we got from the Bloomberg terminal. So you can see the polarity for all of the transcripts are actually greater than 0, which makes sense because typically management in earnings call want to express optimism. And so we didn't get any data points that were below 0. And then the other interesting, pattern we saw was that there was some correlation between, at least linear correlation between the polarity and the 6-day return. So clearly, as positive, polarity increased, more positive sentiment, the spread decreased, which means less risk, which we expected. And so next, just the results and limitations. So first, to figure out if this model was actually accurate, we collected 19 new transcripts to test our model. And this is because these were somewhat hard to get, and we didn't exactly scrape any websites to gather these, so we did them somewhat by hand. So we used 19, and using that linear regression model, this equation line, and putting in the polarity score for these new 19 transcripts, we were able to predict whether they would go up, the spread would go up or down. And that's ultimately what this picture is on the right. You can see whether a spread went up or whether it went down. And we can see that 13 of these were predicted correctly and not 6 weren't. And on the right, you can see if if you have randomized these ones and negative ones and iterated this process a million times, the average would be 9.92 estimated correctly. So it indicates that there might be some chance that this model is correct because we saw 13 off the bat. And again, only 19 transcripts, so obviously a lot of room for error. And then next, I wanted to run a little machine learning on the data. And this is a decision tree, and using bag of words, I was able to print these charts, which show us, first one shows us the most impactful words. So the ones that caused either a large increase or decrease in the in the spread. So some of these don't make sense, and these are because these are more stop words we should probably remove, but some of them do, like Wuhan and hoarding and outflow. Those are some words that maybe are predictive. And then we did the same thing with bigrams, which are just 2 words. And then we ran this decision tree, which shows us, on the top, which words are most important, essentially which word, and then it splits it down. If it has the next most important word, it goes here. If it doesn't, it goes here. If it, and essentially using this, we were able to get a mean squared error of 0.002, which is fairly low. But like I said, there's a lot of limitations, and one of these is the data quality and availability. So especially when it comes to the Bloomberg, there's missing CDS data, especially when you're gathering it from the CDX index on Bloomberg. During years, some of these CDSs weren't even in the CDX, so there were a lot of missing dates and missing spreads that we had to kind of remove from the frame, which really eliminated a lot of the training data set we can use. And then obviously the linear, the model, the correlation or the relationship between the polarity and the 6-day return isn't necessarily linear, but we assume that in the model. And this, this it could be quadratic, it could be, anything. So there's no reason really we use linear, but just for the simplicity's sake. And yeah, pretty much these these because of these reasons, I don't think it's worth using this model to actually trade CDSs, but I think it's interesting to see if there's any relationship between um, the language in earnings call and the movement in spread, and therefore the actual risk inherent in the company. Sure. Thank you.